All right, so we are going to continue on with section 3.4, part 1. And what I want to go over now is all of the different types of partial fractions that you will see. So you have to be able to look at the equation that they're giving you, the rational function, and determine from the rational function which one of these three types of partial fractions we're going to have to use. So when looking at a rational function, which we talked about, a rational function, it's just a function with multiple functions within a fraction. So we need to be able to recognize these three different types of rational functions. Differences are all in the denominator. So when we are looking at these differences here that they're talking about, we're always looking in the denominator. This isn't anything that has to do with the numerator, only with the denominator. Okay? So we are going to look for simple linear factors. The example that we just did, they were all simple linear factors. So an example of that would be x minus 1, x minus 2, x minus 3, x plus 3, we'll change it up a little, and then an x. Okay, so that's an example of just linear factors. Repeated linear factors, an example of repeated linear factors is if we have x minus 1 cubed, and then x minus 2 squared. So these linear factors would be repeated. We could write those out. So we have x minus 1 3 times and x minus 2 twice. And then quadratic factors is going to be something that cannot factor. Okay, so a quadratic equation that is unfactorable. Okay, so each one of these types is going to have a different partial fraction setup. So let's look at all of the different setups that we're going to have to do for each one of these types of denominators that you might see. Okay, first type, simple linear factors. This is an example, 2 over x minus 1, x plus 2. The denominator factors nicely to linear equations, and there's no exponents anywhere, whether it's on the inside of the parentheses or on the outside of the parentheses. The partial fraction setup is going to be very simple. We can split up both of those factors and put just a single variable in the numerator that represents a constant. So that a represents a constant, the b represents a constant. Okay, type 2, repeated linear factors. So the denominator factors nicely, however we have one factor, in this case, that repeats itself multiple times, in this case 3 times. So how do we define that, or how do we see it? The denominator factors nicely to linear equations, but one of the factors occurs multiple times. I guess I should have changed that to at least one of the factors, because it can happen with multiple factors. So causing a nice factor, but with an exponent. So the partial fraction setup in this case would be 1 over x plus 3, a over x plus 3 plus b over x plus 3 cubed squared plus c over x plus 3 cubed. So you see that linear factor, we have to take each one of the options that we might have. So just notice the degree on the x plus 3. We have to have each one of those degrees leading up to the highest degree. And then just the plus d over x minus 2 to include that last factor. But notice how we did the factor that was raised to the third power. We have that factor 3 times, with each one of the factors 1, 2, 3 of the exponents. Okay, so that's repeated linear factor. Okay, and type 3, the last type, is going to be quadratic factors. So an example of that, notice that in the denominator now we have a quadratic equation that cannot factor anymore. So our denominator has at least one factor that will not factor into linear factors. That's a quadratic factor. So a quadratic factor that cannot be simplified. So the partial fraction setup for this is we're going to have one fraction with x as the denominator, one fraction with x squared plus 1 as the denominator. So we have just a over x, that's like all the other ones that we've done. However, when we do the x squared plus 1, we are going to have to put a bx plus c. So our numerator now becomes a linear equation instead of just a constant, whereas all of the other numerators were just constants. So pretty much thinking of it as we need to be 1 degree less. The numerator needs to be 1 degree less than that denominator if it's not factorable. Okay, let's move on to some examples. All right, example number 1 is just looking at the setup here. So we have 16 over x minus 1, x plus 2, and we want to rewrite that in the form of f of x over x minus 1 plus g of x over x plus 2. So they're writing this in function notation because they don't want to give away to you whether or not that's just a constant or whether or not it needs to be like a linear equation. So they just don't want to give any information away. Now when I go ahead and start to solve these, I'm going to change that f of x to an a and change the g of x to a b because it's easier to do, and yeah, this would be too confusing to try to multiply all those terms through. So what type of function will the numerators f of x and g of x be? F of x, well, this is just, both of these are just linear equations, so this is a type 1. They factor nicely, they're both linear, there's no exponents anywhere throughout, so the numerator is going to be just a constant for the first factor and just a constant for the second factor. So f of x is going to be a constant and g of x is also going to be a constant. All right, let's look at the next one. Okay, next one. So what do we notice this time? Now our factors are a little different. So we've got our first one is a linear equation. That one looks good. But the second one, we notice that one is a quadratic equation and we cannot factor it anymore. So this is going to be the type 3 where we are going to f of x is just going to be a constant because that's just a linear equation. So just a constant for the first one. But for the second one, for g of x, that one is going to have to be ax plus b because then it is not a linear term and we cannot factor it anymore. All right, example number 3. The partial fraction decomposition of 12 over x squared minus 4 can be written in the form of f of x over x minus 2 and g of x over x plus 2. First thing that we want to do is decide what f of x and g of x are going to be. Now x squared minus 4, it can factor nicely. So x minus 2, x plus 2. And we could have figured that out easy enough because of the format they told us to write it in. So these are both nice linear factors. So we're going to say that f of x is equal to a and g of x is equal to b. So now let's go ahead and write out our equation. We have 12 over x minus 2, x plus 2, and that is equal to a over x minus 2 plus b over x plus 2. So what we're doing, we just want to split up these fractions. That's all that we're doing. Let's split up the fractions and let's figure out what the numerators would be if we had to split these fractions apart. First thing we do with rational functions is get rid of the fraction. We do not want that fraction to be there. We can multiply both sides of the equation by the least common denominator, which the least common denominator in this case is x minus 2, x plus 2. So multiply that through to every single term. It's going to cancel everything on the left-hand side, and we're going to be left with 12. Here, the x minus 2's are going to cancel, so we will have a times x plus 2. I'm not going to show the step every single time. I know you guys probably already get this easy enough, but I'm going to go through it a couple times. So x plus 2 here will cancel when we multiply to that term. Already multiplied to that term. So the x plus 2's will cancel, and we will have b times x minus 2. Okay, so from here, now we've got rid of all of our fraction, and that was our goal. We wanted to get rid of all the fractions. So no more fractions. Now we need to get rid of parentheses. So we have 12 equals ax plus 2a plus bx minus 2b. All right, now I want to combine my like terms. So I'm going to bring my x's together. So I have ax plus bx plus 2a minus 2b. So now our constants we have together. Here's our x variable. I want to factor that x out. So I have 12 equals a plus bx plus 2a minus 2b. So on the left-hand side, what do we notice? This happened in the last one that I did also. We have a constant term to match it up to. So our 2a minus 2b, we know that that needs to equal 12, but we don't have anything to match up our x variable to. So we need to add that on. So we're going to add in front of the 12 a 0x just for a placeholder. So now we can take a plus b must equal 0. And then also 2a minus 2b must equal 12. So 2a minus 2b must equal 12. Now we have a system of equations that we need to solve. So let's take this first one, multiply everything by 2. My b's will cancel out. So we would have 2a plus 2b equals 0. 2a minus 2b equals 12. I think we've got everything in there, okay? All right, so my b's are going to cancel. And then we have 4a is equal to, add those, 12. So we have a equals 3. Plug that back in. If a equals 3, then b must equal negative 3. So on this particular question, all they're asking for is what is f of x and what is g of x. So I would just go back and I would say f of x is equal to 3 and g of x is equal to negative 3. And that's all you need to do for that one. Okay, for this example, I'm going to start going through them a little bit faster. Again, we have here a equals f of x and b equals g of x. They are both linear, nice linear factors, so I don't have to worry about doing anything differently with those. All we have to do is put in a and b for f of x and g of x. So let's go ahead and write out 16x minus 38 over 8x squared plus 14x minus 15. Now they gave me what that factors to, so that was very nice. That factors to 2x plus 5 plus b over 4x minus 3. So you can see we're just trying to ease it into this partial fractions pretty slowly. So multiply both sides by 2x plus 5, 4x minus 3. Okay, remember you're distributing that throughout the whole equation. Everything's going to cancel on the left-hand side. We have 16x minus 38. The 2x plus 5 is now going to cancel, so we have a times 4x minus 3 plus b times 2x plus 5. Multiply that through. Get rid of our parentheses. We have 4ax minus 3a plus 2bx plus 5b. Okay, I'm going to put my x's together and I'm going to factor out that x at the same time. So I'd have 4a plus 2bx plus 3a plus 5b for my constants. Okay, so now we can match things up here. I have just a minute left on my video, so hopefully I can get through this whole thing. I might pause it here for a second and then just give you the answer. So 4a plus 2b is equal to 16, and then 3a plus 5b is equal to negative 38. That's supposed to be a 2b. Let me fix that. Okay, so I discovered a mistake here. I forgot my minus 3a. There we go. So multiply that, then we're going to multiply this one by 3, multiply this one by 4, so we get 12a plus 6b equals 48, and then negative 12a plus 20b equals negative 152. So put those together and solve for a and b. I'm going to pause because I'm almost out of time, and then I'll show you the answers. Okay, so I just took those two equations, used them as a system of equations there, solved for b, and then solved for a, and then put that in for f of x and g of x. So I get f of x would be equal to 6, and g of x would be equal to negative b. So if you need to pause it and go through the work that I did there, that's